In this video, we examine derivatives of logarithms and look at two examples. So, we've established in our previous discussions that the area under the function of 1 over, let's call it t, from a lower bound a to a variable upper bound x behaves and exhibits properties of a logarithm and is in fact the natural log of said variable. And we use this fact in the fundamental theorem of calculus to say that the derivative of ln of x is simply 1 over x. And we will use this fact to evaluate the derivatives of the functions of the two examples. In the first example, we're given the function ln of x to the fifth and asked to write down its derivative. There are two possible methods we can use to solve this problem. First method is to solve this problem by using the chain rule. We recognize that we have a composite function, so ln of some function, and so we simply multiply the derivative of the outer ln portion of the function, which is 1 over said function, and multiply by the derivative of the inner function. So in our case, we have 1 over x to the fifth times the derivative of x to the fifth, which by the power rule is 5x to the fourth. So the x to the fourth cancels in the numerator and the denominator, and we're just left with 5 over x. The next approach we can use is to use the rule of logs, which simply stated when we have the argument, when the argument of the ln operator is x or whatever variable raised to an exponent, well, we can just rewrite that as that exponent times the natural log of simply the base. So in our case, instead of saying ln of x to the fifth, we can just rewrite it as 5 ln x and take the derivative of ln of x, which we know to be 1 over x, and then we have our answer 5 over x, which agrees with our first method. The next example, we're given the function log base 10 of x, and we're asked again to find the derivative. So we apply the change of base formula discussed in previous videos, and this results in the transformation of log base 10 of x to ln of x over ln 10, and this is the result of the transformation. And we notice that 1 over ln 10 is just a constant, so we factor that out and we evaluate. We're left with the desired form, and we evaluate the derivative of ln of x. And so we have 1 over ln 10 times 1 over x, and that's equal to 1 over x times ln 10, and that's our final results, and we are done.